Bismillahirrahmanirrahim. Today we will study chapter 11, friction and lubrication. This is the second last lecture of this subject or this series of IC engine. And the last topic of today's lecture is friction and lubrication, chapter 11. Okay, we have talked about all the processes which are happening inside and outside the engine, starting from going air fuel mixture inside the engine and then developing a power, then exhaust gases and how to treat those exhaust substances. Then we talked about the cooling system. And now the last topic related to the internal combustion engine is friction and lubrication. Now let's see in general terms what is the friction in engine. Friction refers to the forces acting between mechanical components due to their relative motion. Friction is always due to the relative motion between the moving components and to the forces on and by fluids when they move through the engine. When we applied some fluid or in between those mechanical components, then the forces behavior on that fluid, what is happening, that is the study of the friction. A percentage of power generated within the engine cylinder is lost to friction. There are friction losses as we have studied in chapter 10 and previous, with the reduction in the resulting brake power. So the loss in friction results in a reduction in brake power obtained off the crankshaft. Moreover, accessories that run off the engine also reduce crankshaft output and often classified as part of the engine friction load. As we have discussed that this is the parasitic load. So parasitic loads, the accessories, they are also moving like water pump, supercharger, or any other accessory which are attached to the engine. So they also develop some friction, and the more some 1/3 of the engine power which is developed as we studied in chapter 10, that is gone to the friction load or friction losses. Now mechanical friction and lubrication. In general, when two solid surfaces are in contact in an engine, they touch each other at the roughness high spots of the surfaces. The smoother the surfaces are machined on a microscopic level, the lower will be the surface high points, microscopic, and less will be the average distance separating them. When we machine any material or any component, there are some rough patches there. Till the time we achieve a high degree of machining, the rough patches will be there like this. This is the upper part, one part of a moving substance, and this is another assembly. So in between they are matting, and these are the rough spots which are rubbing against each other, creating a rough friction force here. So the smoother the surfaces are machined on a microscopic level, the lower will be these surface high points, these high points. Okay. Microscopic, and less will be the average distance separating them. If one surface is moved relative to the other, the high points will come in contact and will resist motion, friction. So if one surface we move these high points of this upper will come in contact with the high point or rough points of this lower surface and will resist motion, and friction will produce. Point of contact will become hot, sometimes to the point of trying to weld together. So sometimes they become so hot with their movement or friction that they try to weld together. To greatly reduce resistance of surface to surface motion, a lubricating oil or fluid is added to the space between the surface. So to reduce this friction or heat developed here, we we induce some fluid or oil here, lubricating oil, so that the lubricating oil reduce or minimize the heat developed here. So motion between engine components highly magnified to show rough surfaces, dry or non-lubricated surfaces showing friction caused by high spots. So these are the high spots where the friction is caused, and you get a welds arrangement like this. But if we place some oil here or fluid here, and then again the process of moving is there. Then the forces will be acting on this lubricating oil. So lubricated surface showing reduction of friction by hydraulic floating. So there will be shear forces here. So the lubricating oil or fluid adheres to the solid surfaces. It will adhere in these gaps. Okay. And when one surface moves relative to the other, oil is dragged along the surface. So when we are moving this surface, the oil which is present here will be dragged along. So it will create a thin film between two matting surfaces. So oil is dragged along the surface. The oil holds the surface apart and one surface hydraulically floated on the other surface because of the presence of the oil or the fluid which we are using in between the two matting parts. That oil holds the surface apart and one surface is hydraulically floated on the other surface. The only resistance to relative motion is the shearing of fluid layers between the surface. So the only resistance to relative motion is the shearing of fluid layers. So there will be layers in the fluid which will have a shearing resistance between the surfaces, which is order of magnitude less than that of dry surface motion, which is order of magnitude less than dry of surface motion. Now, the important characteristic of a lubricating oil or a fluid, these are the following. It must adhere to the solid surface, so it does not chip off or wash off when you are applying on a solid surface. So it must adhere, it must stick to that solid surface. It must resist being squeezed out from between the surfaces even under the extreme forces applied in an engine between some component. If huge amount of force is being applied, so it must resist being squeezed out. It must retain its position no matter what how strong the shear forces are. So it must resist being squeezed out from the surface between the even under the extreme forces experienced in an engine between some component. It should not require excessive force to shear adjacent liquid layers. So these resistance forces are not such strong that we require some excessive force to shear adjacent liquid layer. So remember this thing. The property that determine this is called viscosity. Very important thing. While we're discussing the lubricating oil or fluid, viscosity is the parameter with which we can determine that the liquid, fluid, or oil is, or the lubricant is good or bad. So I read again, it should not require excessive force to shear adjacent liquid layers. So first, in first part, we are having a two metal parts, they are moving. Then we applied oil or fluid there, that is the lubricant. So it should adhere to them, it should resist being squeezed out, but it should not require some excessive force to shear the adjacent liquid layer. The property that determine is called viscosity. Now, these were the two metal parts which are moving together. Now let's see what is happening inside the bearings, because a lot of bearings are used in the engine. Bearing offer a unique lubrication problem because one surface race surrounds the other surface shaft. So if you have seen the bearing, we have an inner race, we have an outer race. So the bearing offer a unique lubrication problem because one surface race surrounds the other surface shaft. When an engine is not in operation, gravity pulls the shaft in any bearing, crankshaft, connecting rod down and squeeze out the oil film between the two surfaces. So when engine is not in operation, the gravity to gravity, the weight, the lower portion will be in contact and it will squeeze down and the oil film between the two surfaces. In operation, the combination of rotating shaft, viscous effect, and dynamic forces from various direction results in a hydraulic float of the shaft offset slightly from the center. So like this, slightly offset with the thickness of delta. When the engine is not in operation, gravity pulls the shaft in any bearing, crankshaft, connecting rods, etc., down and squeeze out the oil film between the two surfaces. In operation, when the engine is in operation, the combination of the rotating shaft, viscous effect, and dynamic forces from various directions results in a hydraulic floating of the shaft, offset slightly from the center, as we have seen in the figure. The position and thickness of the minimum oil film in the bearing will depend on tolerances, load, speed, and oil viscosity. So the offset position depends upon the thickness of the minimum oil film in the bearing, will depend upon tolerances, load, speed, and oil viscosity. It will be on the order of 2 mu, and 1 mu is equal to 10 raised to the minus 6 meter for a main bearing in an engine. So let's see on figure A. It's a non-rotating lubricating oil is squeezed out and surface contact surface. We have this bearing, and it's due to gravity and weight. It is resting on this outer portion. So the oil is squeezed out from this portion. Okay. When it is rotating, oil film is dragged by a moving surface and surface separated by a thin liquid film. So this, you see, this is a gap here. So this is due to the thickness of the oil film which is present here, and it is slightly off center. Now, in engine, we have three basic type of oil distribution system used in an engine. As we have a cooling system, it requires a water pump to flow, complete the channels of the circulation. So in lubrication, we have three different types of systems which are used in the engine. First one is the splash. Second one is the pressurized. Third one is the combination of these two. So these three were used in practice. Previously, it was only splash, then we comes to pressurized. Now in modern engines, we are using the combination of these two. Let's study one by one. Splash system. The crankcase is used as the oil sump reservoir in a splash system. The crankcase or the oil sump reservoir is used as oil sump in a splash system, and the crankshaft rotating at high speed in the oil distributed to various moving parts by splashing. No oil pump is used. Basically, the dynamic weights which balance the crankshaft, basically those are interacting with the oil reservoir. So they produce splash in the crankcase, and that splash goes to the different parts, moving parts. Oil is circulated by this phenomena by splash mechanism. So no oil pump is used. All components includes the valve train and camshaft must be open to the crankcase. So all components, including the valve train, camshaft, which are moving parts, must be open to the crankcase so that the oil flows by splash is happening there. Oil is splashed into the cylinders behind the piston and onto the back of the piston crown. So due to this splashing arrangement by the crankshaft, it is splashed behind in the cylinder, behind the piston and onto the back of the piston crown, acting both as a lubricant as a coolant. Many small four-stroke cycle engines, lawn mowers, golf carts, etc. use splash distribution of oil. Now, the second system, the pressurized system. An engine with a pressurized oil distribution system uses an oil pump. So the difference is here, we do not use the crankshaft to splash the oil. We use oil pump here to distribute that oil to have the lubrication system. So an engine with a pressurized oil distribution system uses an oil pump to supply lubrication to the moving parts through the passages built into the component. So these are the passages which are built in the moving components. So oil is pressurized into those channels to lubricate them. A typical automobile engine has oil passages built into the connecting rod. So drilled hole through and through is built in the connecting rod, valve stems, push rods, rocker arms, valve seats, engine block, and many other moving components. So passages are built so that the oil move in those in paths to complete circulation. These makes up the circulation network through which oil is distributed by the oil pump. In addition, Oil is sprayed under pressure onto the cylinder walls and onto the back of the piston crown. So beside these circulation networks, the oil is also sprayed on the cylinder walls so that the piston in the oil cylinder walls are lubricated, and on to the back of the piston crown so that the piston crown should not heat up. Most automobile actually use dual distribution system. So in modern vehicles, the dual combination of splash and pressurized system are used. That is the dual distribution system, relying on splash within the crankcase in addition to the pressurized flow from the oil pump. So both the splash system and the pressurized full flow oil system is used in modern vehicle. Most large stationary engines also use this kind of dual system. No, I'm talking about the aircrafts because they are also internal combustion engines, but their role is different. Most aircraft engines and few automobile engines use a total pressurized system with the oil reservoir located from the crankcase. So instead of having oil in the oil sump or the crankcase, they have a separate oil reservoir or tank from where they draw the oil and pump it to the various locations. These are often called as dry sump system. So there are two things, dry sumps and wet sumps. Wet sumps are those sumps in which you have the huge quantity of oil in the crankcase or the reservoir. Dry sumps are those engines in which you do not have a huge crankcase in which you store the oil because you use separate oil reservoir or separate location to store the oil. So these are where engine do not have the oil in the reservoir. These are called dry sump system and wet dry system, are those in which you have the oil in the crankcase. Aircraft do not always fly level, as we know, and uncontrolled oil in the crankcase may not supply proper lubrication or oil pump input when the plane banks or turns. So you need to have some pressurized oil flow system. A diaphragm controls the oil level in the reservoir of a dry sump system, assuring a continuous flow into the oil pump and throughout the engine. So we need some specific arrangement to cater for this gradient in the flight. So we need a diaphragm control the oil level in the reservoir of a dry sump system, ensuring a continuous flow into the oil pumps and throughout the engine. Combination of pressurized and splash. Let's first see what it is. Here we have this crankcase or the oil sump. Okay, this is the oil. Main oil gallery, bypass valve, filter feed gallery, main bearing channel, connecting rod with channels. So let's see. This is your oil reservoir here. Oil is present here. This is your crankshaft. This is your connecting rod. And the oil is flowing through the splash here and also going to from the oil pumps to the oil filter, and then it goes to the rocker arm and walls, and then in the circulation it coming back to the engine. So both the splash system and the pressurized system is used in the engine. Now, basic characteristics of an engine lubricating oil. What are the basic characteristics of an lubricating engine oil? It must serve as a lubricant. The first property of any engine oil or lubricating fluid is that it must serve as a lubricant. Second, a coolant. So this primary task is to act as a lubricant, and secondary task is to act as a coolant. And it must serve as a vehicle for removing impurities. All the metal parts which are moving, there is some wear is going on. Okay, so it extract and those impurities with the oil and back to the filter or the sump. Fourth is the slow down corrosion. So it slow down the corrosion between the parts. It must be able to withstand high temperatures without breaking down. So it should have this quality that it should withstand the high temperature without breaking down, means its chemical and physical properties remain the same through a wide range of temperature. must have a long working life. So it's have a life period should be long. You do not require a frequent oil change, stability over a wide temperature range. So it should have a stability over a freezing temperature and mild temperature and extreme hot temperature. So these are the basic properties or characteristics which a lubricating oil must have. Now, lubricating oil which we are using have different additives inside in it. So to enhance different properties, what are the additives which we use in the lubrication system or lubricant fluid or lubricant oil? It must be anti-foam agent. The additives of the lubricant must be anti-foam agent. So there should be no foaming in the lubricating oil. Oxidation inhibitors. It should be oxidation inhibitors. 4-point depressant, anti-rust agent. So anti-rust agent, detergents, anti-wear agents, friction reducers, viscosity index improver. So these are the properties which you look for in additives of a lubricant. Anti-foam agent, oxygen inhibitors, 4-point depressant, anti-rust agent, detergents, anti-wear agents, friction reducers, viscosity index improvers. Now let's talk about the viscosity, the important factor while discussing about the lubricating oil or fluid. Lubricating oils are generally rated using a viscosity scale established by the Society of Automotive Engineering. So oil are graded by their viscosity scale. Dynamic viscosity is defined from the equation tau s is equal to mu differential of u divided by differential of y is equal to mu delta u divided by delta y, where mu is the dynamic viscosity of the lubricating oil. Differential of u divided by differential of y is the velocity gradient between the surfaces. Delta u is the velocity difference between adjacent surfaces, and delta y is the difference between the adjacent surfaces. So this is the dynamic viscosity or the in terms of shearing. The oil with lower numbers are less viscous and used in a cold weather operation. So oil grade which is having a lower number of viscosity grade or less viscous are used in cold weather operation. Those with higher number are more viscous and are used in modern high temperature, high speed, close tolerance engine. So those with having a high number of viscosity grade or more viscous are used in modern high temperature, high speed, close tolerance engines. If oil viscosity is too high, it means it's a thick oil, then more work is required to pump it and to shear it between moving parts. So if the viscosity grade is too high, it means it's a too thick oil. So you require a high pump work to make it work, to make it flow between the moving parts. This results in a greater friction work and reduced brake work and power output. So if it is a high viscosity grade oil, then this results in a greater friction work and reduced brake work and power output. Fuel consumption can be increased by as much as 15% if you're using high viscosity grade oil. Starting a cold engine lubricated with high viscosity oil is very difficult because the starting motor has to do a lot of work to move that cold engine and the cold oil. Okay. Now the chart, the dynamic viscosity as a function of temperature for common engine oils. On our x-axis, we have temperature in Celsius ranging from 10 to 150. On our y-axis, we have dynamic viscosity mu, that is kilograms per meter seconds, from 0.001 to 5. So as you see, as the grades increases from 10, 20, 30, 40, and 50, you require a more temperature. At 40, this SAE 10 require this much of this dynamic viscosity. But at that temperature, the dynamic viscosity of SAE 50 will be more. So The common viscosity grade used in an engines are like this: 5, 10, 20, 30, 40, 45, and 50. Now, this multigrade oil, instead of a single oil having a different velocity number, we are using multigrade oils. Multigrade oils was developed so that viscosity would be more constant over the operating temperature range of an engine. So multigrade means we are mixing two types of viscosity oil was developed so that the viscosity would be more constant over the operating temperature range of an engine. When certain polymers are added to an oil, so we add certain polymers, and that all polymers, what they do, the temperature dependency of the oil viscosity is reduced. These oils have low viscosity number values when they are cold and high numbers when they are hot. So these polymers do these tricks. These oils have low viscosity numbers, viscosity values when they are cold and higher numbers when they are hot. As a value such as SAE 10W30. SAE 10W30 means that the oil has a property of 10 viscosity when it is cold, W stands for winter, and 30 viscosity when it is hot. This gives a more constant viscosity over the operating temperature range. When the engine and oil are cold, the viscosity must be low enough so that the engine can be started without too much difficulty. So it's like this. This gives a more constant viscosity over the operating temperature range. When the engine and oil are cold, the viscosity must be low enough so that the engine can be started without too much of a difficulty, so less of a load on a starting motor and a crankshaft. High temperature reduces the viscosity, and the oil with low viscosity number would not give adequate lubrication. So you got a different grade there. Dynamic viscosity as a function of temperature for multi-grade oil as compared to single oil. If you use multi-grade oil, so you can see the dynamic viscosity with a wide range of temperature. Common oils available in the market, in the commercially, those are SAE 5W20, ranging from this to SAE 20W50. On this slide, I normally take a quiz, general verbal quiz from my students, seeing on all these grades and studying all this. Which oil will you recommend for your own vehicle? So this is a question for my students. Now, instead of single oil, then we have a multi-grade oil. Then, and now we are using synthetic oils. More advancement in the technology. A number of synthetically made oils are available that gives better performance than those made from a crude oil. So let's see, they are better at reducing friction and engine wear. So synthetic oil, they are better at reducing friction and engine wear, have good detergent properties, and which keeps the engine cleaner, offer less resistance for moving part, so less resistance for moving parts, so easy starting, and requires less pumping power for distribution, so easy to move around in the channels. They are better at reducing friction, number one, and engine wear, have good detergent properties, which keeps the engine cleaner, offer less resistance for moving parts, and require less pumping power for distribution. With good thermal properties, they provide better engine cooling and less variation in viscosity. So synthetic oils with the good thermal properties, they provide better engine cooling and less variation in viscosity. Because of this, they contribute to better cold weather starting and can reduce fuel consumption by as much as 15%. So by the help of using that synthetic oil, and with their good thermal properties and these properties, they provide better engine cooling and less variation in viscosity. Because of this, they contribute to better cold weather starting and can reduce fuel consumption by as much as 15%. These oil cost several times as much as those made from the crude oil. So the disadvantage is, or demerit is, that they are expensive as compared to the crude oil. However, but On the other hand, they can be used longer in an engine with a life period of 24,000 kilometers, being the oil change period suggested by most of the manufacturer. So once they are expensive, but they have more life. So they compensate in this way. Available on the market are various oil additives and special oils that can be added in small quantities to standard oils in the engine. These claims with some justifications to improve the viscosity and wear resistance property of normal oils. Whatever in local market the people are doing, they are mixing two different oils and producing their own oil and claiming that this is a good oil for the engine, but don't use those. One major improvements that some of them provide is that they stick to metal surface and do not drain off when the engine is stopped. So one of the property is that of synthetic oil is that major improvement is that some of them provide it is that they stick to the metal surface and do not drain off when the engine is stopped, as most standard oils do. The surface are thus lubricated immediately when the engine is next started. So there is a less wear while starting the engine because of these synthetic oils. So here we end our lectures today, first part of this chapter. And second part we'll cover the rest of the chapter.